We're starting off with a cosine function on this one. Our a value, what we're multiplying outside the function, is -3, so our amplitude is 3, that's the vertical stretch. What we're multiplying by x is 2 pi, so our period will be 2 pi divided by 2 pi, or 1. We don't have a vertical shift on this one. That pi over 4 that we're subtracting is inside the parentheses, not outside. To find our left endpoint, we set everything inside the parentheses equal to 0 and solve for x, adding that pi over 4 to both sides. When I divide by 2 pi, that goes in the denominator to be multiplied with the 4. Our pi's cancel, leaving us with 1 over 8. To find our right endpoint, we set everything inside the parentheses equal to 2 pi and solve for x. Adding that pi over 4 to both sides, we will need a common denominator, which is 4. So we have 8 pi over 4 plus pi over 4, which gives us 9 pi over 4. Again, dividing by 2 pi, we'll put it into the denominator with the 4. Pi's cancel, we get 9 over 8 for our right endpoint. Our period was 1, which means when we divide that by 4 to scale our x-axis, we get 1/4. We're going to get a challenging one, just like example 1, where the 1/8 and the 1/4 do not match up, so we have to find a common denominator to get our x-axis scaled appropriately. The scales that I have set up are 1/4 for the quarter of a rotation for our full period of 1, and the 1/8 will be exactly halfway between. That's where our phase shift will start, and then we add a 1/4 or 2/8 to get 3/8, plus another 2/8 to give us 5/8, plus another 2/8 to give us 7/8, and we need one more because we know that our right endpoint will be at 9/8. Subtracting that 2/8 off to the left, we get -1/8, -3/8, -5/8, and -7/8. Our amplitude is 3, so we're going to scale our y-axis accordingly. We're graphing our cosine function, which typically starts at the maximum, but we had a vertical reflection. Our a value was negative, so cosine will start at its minimum at the phase shift of 1/8, back up to 0 at 3/8, up to its maximum, back to 0, and back to where it started down to its minimum. Doing the same thing off to the left, again skipping that y-axis, we're going back to 0, back to its maximum, back to 0, down to its minimum. For our last example, we're going to write the equation of a function from the graph. Now, because sine and cosine functions are actually phase shifts of one another, we can choose which function we want to write the equation for. Do we want to look at it starting at its maximum, like cosine? We could give it a vertical reflection and start at its minimum, or we could use sine and start at one of its zeros. There's lots of different correct ways to write an equation of a sinusoidal graph. Of course, there are some things that both the sine and cosine function have in common, such as the a value or the amplitude, so we can figure that out before deciding which trig function we want to use. To determine the amplitude, you take the maximum that the graph reaches minus the minimum, and you divide it by 2. 2 minus -4 is 6, divided by 2 is 3. Our amplitude is 3. The a value can be 3 or -3 if we want to give it a reflection. Let's keep it a little bit more basic, so I'm going to stick with +3 for our a value. Our next job is to figure out what the period of this function is. Because both sine and cosine have the same period for their parent function, we still don't have to decide if we're writing an equation for a sine or cosine function. It needs to complete one full rotation, for example, from maximum to maximum, or we could look from minimum to minimum, Or we could try and find the zeros, which are slightly trickier on this graph, and go from a 0 up to a max, down to a min, back to 0. Because they're both positive, I'm going to go from minimum to minimum, figure out what these values are in between my scales. My scale, it might be a little hard to read, the graph goes over it. This is pi over 4. This is pi over 2. This is 3 pi over 4. It looks to me like the minimums are hitting halfway between, so I'm going from pi over 8 to 5 pi over 8 for one full period of this graph. Subtracting those two values, 5 pi over 8 minus pi over 8 gives me 4 pi over 8, which simplifies to pi over 2. That's the period of this function. So to find b, remember typically we do 2 pi divided by b to get the period of the function. Well, this time we know the period and we need to solve for b. The easiest way to solve this is to treat it like a proportion, cross multiply and divide. So I get 2 pi times 2 equals pi times b. Dividing both sides by pi to solve for b, my b value is 4. Next, we need to figure out the vertical shift. The principal axis is halfway between the maximum and the minimum. So halfway between 2 and -4 is -1. This graph was shifted down 1, so -1 is my d value. Determining our left and right endpoint is where we really need to decide, do I want to write an equation of a sine function or do I want to write an equation of a cosine function? Looking at this graph, sine starts at 0. If we write an equation of a sine function, we do not have a phase shift. Our c value will be 0, which of course makes our life so much easier. However, as my job is to teach you how to write equations, that would be doing you a disservice if we just went with the sine function. So we're going to take a look at writing a cosine function for this graph so we can practice with those phase shifts. Cosine starts at its maximum. You can pick any maximum point and decide that that is your left or right endpoint. I decided to start at that negative pi over 8, and then my right endpoint would be at 3 pi over 8, halfway between that pi over 4 and pi over 2. I identified my left endpoint as negative pi over 8, and my right endpoint as 3 pi over 8. Remember, when we set up those equations to solve for the left and right endpoint, we ended with x equals. So I'm going to substitute 4 for b. You can choose either endpoint. I'm going to use the left endpoint because then it equals 0, which is slightly easier, plus c equals 0. And once we solve this equation, we'll have our c value. Negative 4 pi over 8 simplifies to negative pi over 2. Adding that to both sides, my c is pi over 2. Putting all of that together in my cosine function, I have y equals, the a value is 3 times the cosine of b value times x plus the pi over 2 that we solved for c minus our d value of 1. Again, be sure to let me know what questions you have, what you're struggling with, so we can start our time productively and I can get those cleared up for you.